These are the problems on the bottom of page 4 of the study guide for algebra benchmark number 2. So we got two mixture problems. Let's take a look at the different types here. I've written a portion of the chart, just don't have a whole lot of room, so I wasn't able to write the whole thing. So anyhow, a solution, it's the amount of solution times by the rate equals the amount of salt. So with solution problems, we've got two different parts. We've got pretty much like part number 1, part number 2, and then we have the total, or the mix. And so when we look at it, it says a solution contains 30% salt. A solution contains 30% salt is to be mixed with one containing 50% salt. To make, this is the key phrase here, to make tells us that now that is the mix. So the mix is going to be 200 liters. So right away I know the total, or the mix, is 200 liters of a solution containing 42%. So 42. So we're going to multiply 200 times 42, but we've got some other parts here. So we're mixing two different amounts. Now remember, one of the rates is always low and one is high, and you're going to get a mix that's in between those two. So we don't know either one. It says how much of each solution do we need. So let's say they wanted the 30%. Well, if they wanted the 30, that's where you put your x. If they want just the 50, that's where you put your x. So it kind of depends on the type of problem. So anyhow, what we're going to do here is we're going to write an expression to represent part number 2. And it's going to be the total minus x. So whenever you're given the total, you're always going to have a total minus an unknown. So what we're going to do from there is put this 200 minus x in parentheses and then multiply these numbers across. So this part's going to be the main part that we're going to end up using. So we use this part to help us come up with this equation. Here we have 30x. Here we have 5 times 2 makes 10. And then we have 1, 2, 3 zeros. And then we have 50 times x makes 50x. Over here we multiply 2 times 42 makes 84. And we have 8400 equals, or actually nothing else. That's it, just 8400. And so from that point, what we're going to end up doing is adding these equations together. See, the two parts are summing to make the total. So I can go ahead and collect these two terms, subtract those numbers, and we end up with a negative 20x and actually plus 10,000 equals 8,400. So now we need to move that 10,000 over to the other side, subtract it. Now when you do that subtraction, you're going to end up needing to put the bigger number on top to get the right answer. So if you kind of think about it, you see if you took 8,000 from 10,000, that'd be 2,000. So if we have 400 more, that's going to be 1,600 is what's left over. And so you kind of work backwards here. You'd go 6 plus 4 makes 10. Carry a 1. 1 plus 8 plus 1 makes 10. So that does work out. And that's a negative, and we have negative 20x here. So when you divide by negative 20, well, one of the zeros is going to cancel out here. 2 goes into 16 8 times, and we have a 0 left over, so 80. Well, what's x represent? X is the 30%. So 80, and then whatever the units are, in this case liters, of 30%. Well, we still have another one, though. We also have the 50%. So you have to subtract. We have to do 200 minus 80. And that'll give us the amount of the 50%. So it's right here, this part right here that I'm working. This is the 50%. That's why I circled that, part number 2. So I figured this part out. 200 minus 80, well, that gives me 120 liters of the 50%. Well, there it is. The first one done. We got another couple problems. So again, you're going to have 2 of these. So let's see what this one looks like. Let's see if it's any different. A 280 liter solution is 20% salt. Okay, that's probably what we're starting with. So we can put that in there. 280 is 20% salt, so times by 20. How much? Oh, that's a question. We don't know how much. So we're going to have x. How much salt should be added to make a solution that's 36% salt? Well, if it's just salt that's being added, it's 100% salt. And so you don't have, it's not like a 90% salt and something else. It's just pure salt. So 100% is the rate. And we want to make, see right here, to make, that tells us that this 36% is our mix. So we put that down at the bottom here. So 36 is our mix. And remember what I had said before. The rates, you're going to have a low rate and a high rate, and the mix is going to be in the middle. Well, how do I write the amount of solution for the mix? Well, here these two are going to end up adding together to make the mix. So it's just going to be 200 plus x. Now when you're given the total, then you're going to have 1 is x and 1 is 200 minus x. But here, it's not that way. Well, we need to multiply. Remember, you're going to use the distributive property there. So here we have 2 times 2 makes 4, and we got 3 zeros. Here we've got 100x. And over here we get double 36 is 72, and then 2 zeros plus 36x. So remember, you're going to end up adding these amounts together. So let's see what we get. Well, we've got an equation, 4,000 plus 100x equals, and then we got 7,200 plus 36x. So we just have to do some opposite operations just to move some terms around. So we got to take that 720 away, and oops, I got to take this 700. Oops, that's 7,200. I should have gone the other way. So I think I'll actually end up doing that way. I don't have to deal with the negative numbers. So let's go ahead and subtract that 4,000 from this side and take the 36x from this side. So when I take that 36 from the from that 100, if you just think of what plus 36 makes that. Well, we need a 4, and that'll make 10, and so you carry the 1 here, and so that'll make 40, and then we have 6 that we have to get up to. So 64x equals, and then we do some subtraction there, and we get 3,200. And so there we have to do some division. And so we have to think about how many times does 64x go into 300 or 3,200. Well, we do the division, and x is 50. So that's what we end up with. So 50, what are the units there? Well, they're liters of the salt. So there it is, 50 liters of salt. Well, let's take a look at another one here. A solution containing 28% chlorine is to be mixed with, so we know it's being mixed with a 40%. So these are the two parts. So we have a percentage, a high percentage, and we are going to make. So again, those words to make, that gives it away. What is the mix? So this is our mix here, and it's 300 liters of a 36% solution. And so from there, we want to find out how much of each is going to end up being used. So call one of them x, one of them the total minus x. So it's just like the first problem there. So we multiply across, we get 28x. Over here we're going to end up with 12, and then we have 3 zeros minus 40x. And then over here we have 3 times 36. Let's see here, that gives me 18, and 9 plus 1 makes 10, so 10,800, because I got to bring down those 2 zeros. So I'm adding this stuff together. Remember, you're going to combine these two, so you got to subtract those two numbers, leaving us with 12x, and it's a negative, and then equals that 12,000. Oops, not equals, but actually just a plus. So let me fix that. So plus 12,000 equals 10,800. So from that point, we need to move some terms around. And so we'll do some opposite operations there. Subtract that 12,000 from each side, and we're going to end up having to think about this here. So if it was 11,000, it would just be 1,000 left over. But since it's 10,800, we have that extra 200. So we're going to end up with a 1,200. And if you think about it, let's see, and it's in negative. See, 2 plus 8 makes 10, so that's going to give me that 0, and then you carry the 1. 1 plus 1 makes 2, so that does end up working out. And so when we do that division, x is going to end up being 100. So 100, what are the units there? They are liters again. Liters of which one does it represent? Well, x is the 28%. So 28%. And so we go ahead and substitute that 100 back in for this portion right here, this 300 minus x. And so that's where I'm getting the 200 once I go ahead and do that subtraction. So 200 liters of the other percent, which is 40% solution. So there it is, our answers. Well, let's take a look at the next one here. So this is a distance, rate, and time problem. So we've got Ted's average driving speed is 80 miles an hour for a 5-hour trip. Well, let's go ahead and start by writing distance equals rate times by time. And they're giving us some information that we have to be able to find out the distance here. So it says the average driving speed was 80 miles an hour for a 5-hour trip. They're giving us the average rate, 80 miles an hour, times by a 5-hour trip. We can multiply those two units and get the distance. 8 times 5 gives me 40, and then add a 0, so 400. This is the total distance right here. So they just gave me that total distance. Well, let's go ahead and look at the next one. During the first 4 hours, so 4 hours, he averaged 65. Oh, okay, they're going to give us another distance. Not the total distance, but just the distance for the first 4 hours. So we go ahead and multiply that. We get 20. So we've got to carry a 2 there. And that makes 24 plus 2 makes 26. All right. What is the speed for the remaining hour? Okay, there's 1 hour left. We don't know what that speed is, but we do know the distance. See what we can do with these two numbers? Subtract them. So we get a 0. We got to borrow here. So borrow from the 4, change it to a 3, and that makes 10 there. So 3 minus 2 makes 1. Whoa, he was really moving. Seems kind of far-fetched, but that's our answer. 140 miles an hour. He must have been in Nevada. Alright, well, let's take a look at the next one. Let's see what that one says. We've got a car leaves town at the same time. 2 cars leave town at the same time, traveling in opposite directions. Okay, so here's one car. Here's the other. Here's the town. And it says one travels 40 miles an hour, the other 45. In how many hours will they be 255 miles apart? So neither car has traveled that 255. One car has traveled X miles, we'll say. The other is, remember, this is a total now, so it's 255 minus X is what we have here. And so we go ahead and set it up. We've got, remember, distance equals rate times by time. So the distance, well, we've got one of them is X. And the other one is going to be 255 minus X. We're going to use those amounts there. Now the rates. What are the rates? Well, we said that, let's say that one that's going slower is X. So that's 40. Now they left at the same time. So we don't know what that time is, but we know it's the same. So we use T. And instead of X, let's go, I'm going to change that. I'm going to change that to make it D so I understand what that variable represents when I go ahead and solve for this. So I'm going to use D instead, I decided. And so what was the faster car? It was traveling 45 miles an hour. So 45, and the time was T hours, because it was, again, the same time. So from that point, all we have to do is do some, I guess we could add these equations together. Let's do that. We got the D's lined up. So 255 equals negative 5T. I'll just divide by negative 5 and we'll have our answer. Well, let's see here. This, actually, I have to add those numbers. I made an error there. So let's fix that right now. So hold on a second here. Alright, so I made an error in here, and the error was I was so busy doing subtraction, canceling out these D's, I subtracted this number. Now I knew I made the error right here because I only had one negative. So whenever you only have one negative on a distance, rate, and time problem, you know something's wrong. I made some sort of error, so it was right here. I should have added those two numbers and get 85. So when I do that division, well, 85 does go in there evenly. It goes 3 times. So there it is, 3 hours, our answer. Well, I'll finish up the other problem in part, I guess 8 or so, or 9, whatever the next part will be, because I ran out of time.